My name is Candy Gilman, and I am the Education and Training Manager for the Artel portfolio for advanced instruments. And I'm very pleased that you're taking time out of your very busy schedules to join me for today's demonstration on the Artel MVS system. A couple of just housekeeping pieces of information. This demonstration is going to take approximately 45 minutes, and it consists of some slides that I'll share with you to talk a little bit about the system and how it can help integrate into your various processes. And then I'll get into a live system demonstration. And lastly, the demonstration is also being recorded. So if you'd like a copy of the recording, maybe you had to step away and there was some things that you missed, or maybe you'd like to share this with a colleague or two, you can certainly feel free to reach out to your account manager or anyone here at Advanced Instruments, and we're more than happy to provide that recording to you. So let's go ahead and get started. So first, let me see if I can elegantly share my screen with all of you. So first, let's talk a little bit about who we are. So we're with a company called Advanced Instruments, and Advanced Instruments is headquartered in Norwood, Massachusetts. And they've been in business for well over 65 years, and their primary business is osmolality, so osmometers. And so some of you may already have some osmometers at your facility. There's a really large install base with Advanced Instruments. And so when we were acquired by them in June 2022, it was a really wonderful marriage of two companies. We had a lot of shared customers and definitely a lot of shared values, with strengths being in technology, development, quality, and support. So it really was a wonderful match. So when we get to the Artel product portfolio, we've been around since the early 80s. We're the global leader in liquid handling quality assurance. And all that means is that if you need to test volume verification on various devices, we provide systems and software that can help you with that. Our products and services help provide standardized quality to all of our customers all over the world. But more importantly, our systems are based on what we call dual dye ratiometric photometry. And essentially what that means is that there's varying concentrations of solutions, or red dye. And the red dye is your solution under test that you'll then measure with your automated liquid handler, your pipette, or other volumetric devices. In addition, low volume liquid verification is really where we excel at. So with the MVS system, we can test with NIST traceable results down to 10 nanoliters, up to 350 microliters in a single 96 well. And last but not least, we consider ourselves a trusted customer-focused partner. So what that means, right, if you take a look at this slide, this is an example of our mission statement. It's meant to be very, very high level. Essentially, we provide products and services that enable you, our customers, to standardize your liquid handling quality assurance, regardless of where you're located in the world. So with us, you can be confident that your pipettes, your liquid handlers are accurate, whether or not you're testing in Boston, Brussels, or Beijing. The technology is the same, no matter where you're located. Now, this slide just outlines some of the system options that we have, some volume measurement options from Advanced Instruments. Our flagship system is the Artel PCS, and that's really designated for single channel pipette devices. But of course, today we're going to be talking about our Artel MVS, our multi-channel verification system. And that system is really geared toward automated liquid handlers, as well as multi-channel pipettes. We also provide automated liquid handling services. So what that means is that if you have some automated liquid handlers in-house and you need to have those volumes verified, but perhaps you're not ready for the purchase of an Artel MVS system, you can buy essentially an 8-hour chunk of time with one of our field application support scientists, and they'll come on site and they'll work with you to get those robots tested. And then last but not least, we also provide pipetting technique certifications, which tends to be a very, very hot topic, especially now. This slide is meant to illustrate how prevalent we are throughout the life sciences. It's meant to show the variety of industries that utilize our technology, but I should point out that in all of these cases, the common thread is to improve the quality of assays. So you might be wondering, there's a lot of different questions on why people will consider the Artel MVS. First and foremost, how do you evaluate the right liquid handler for the job? Is it important for you to have a standardized method that assesses both accuracy and precision across all kinds of different makes and models? And if so, the MVS system can help you do that. There's a lot of customers that also use our system to optimize methods. We're going to talk a little bit more about liquid class optimization as well as other types of optimization in a subsequent slide. And out of the box performance of any robot, any automated liquid handler can be dialed in with various solutions in your laboratory using our system. And then last but not least, what if there's an event? What if you have an automated liquid handler in the laboratory and something happens? Maybe the robot crashes, or maybe you want to evaluate a new type of tip that you're using with your robot. How do you measure equivalency of performance before and after something like that? A standardized method is really critical when you have situations like that appear. So one of the things that we wanted to do is we really wanted to take a look at what's the impact of some of these small changes. What's really the impact of something like 2 microliters? So we took a high throughput screening assay with key components, reagent 1 and reagent 2 compounds that were supposed to be delivered at 25 microliters. And we intentionally varied those volumes by plus or minus 2 microliters to measure the impact of the potency or the IC50 at the conclusion of that test. And if you look at if you look at the bottom right-hand side of the screen, you'll notice that the measured IC50 had a very widespread min to max just by adjusting those reagent volumes by plus or minus 2 microliters. So something that seems fairly small and fairly insignificant can have a really big impact. So as we focus more on this MVS system itself, I just want to kind of talk through some of the components that we validate together as a system for you. So as you can see here, those components consist of a plate reader, a calibrator plate, a barcode reader or barcode scanner, a plate shaker, and a computer with our system software. And then in addition, you've got our Qual-Assure solutions and our characterized microtiter plates. And all of these items are installed on a mobile workstation or cart in your laboratory. So earlier I mentioned that dual dyed wavelength ratiometric photometry. And essentially that means there's 2 dyes that are helping us calculate the volume for you. One dye is red and it's used as the sample. The other dye is blue and it's used as the internal standard to measure the total volume in every well. So all of our dyes are manufactured and characterized in our reference laboratory, and the known absorbance of those solutions are encoded in the barcodes on the sides of the bottles. So those barcodes are what help provide NIST traceability for your results. All of that information that gets transferred into the software using the barcode scanner and we use the ratios of the known absorbances and the measured absorbances on the day of test to help you calculate volumes. And then last but not least, we're able to calculate with accuracy and precision for the entire process, taking less than 10 minutes for both 96 or 384 well plates. It's a really fast process, but you'll see that in just a moment. One of the key components that I mentioned earlier are verification plates. Now, these plates look a lot like your off-the-shelf microtiter library plates, and essentially that's what they are. However, what we do on a lot-by-lot basis is we characterize the performance of these plates. We measure the taper angle of the side walls as well as the bottom diameter, as you can see on the graphic there. And we also perform a normalization across the plate to correct for any variability that might be introduced by the injection molding process of the plate, making sure that every well measures exactly the same as its neighbor. And then all of that information goes into the barcode of the verification plate. So you might be wondering, why is that so important? Well, when you think about NIST traceable results, our verification plates are part of that NIST traceable result that you would receive from our system. And we've got a number of specialized Qual-Assure solutions because we understand and we know that most of our customers are not just testing water on their automated liquid handlers. They're also testing other solution classes such as DMSO or master mix or biologics such as serum or plasma. Our solutions are meant to mimic the liquid handling properties or behaviors of those liquids that you're using. so that they behave similarly to master mix or serum or plasma, respectively. So a number of different manufactured solution classes that we provide with the system. So now we spent a little bit of time giving you an overview about the system. Let me talk a little bit about the MVS steps. So as far as using the MVS, it's very, very simple. Essentially, you dispense the red dye using your liquid handler under test. And then if it's appropriate, you backfill with blue dye, which is what we call diluent solution. Now I want to stop here and just talk for a moment. These two steps can be reversed, especially if you're working with something that's really small volume. Let's say you're working with 50 nanoliters. You might choose to dispense that blue dye or the diluent first, and then perform a wet dispense with the red dye with the 50 nanoliters under test. So these two steps can be reversed. Now, once you've dispensed those two dyes, you have to be able to shake them together, right? So once those dyes have been dispensed into the plate's then shaken on our validated system shaker. We want to make sure that those dyes are mixed together in a homogeneous fashion. And then we'll read the plate at 520 nanometers and 730 nanometers on our plate reader. And then after that reading has been performed, you'll then get your output report that gives you, again, well-by-well results, but also channel statistics and dispense volume statistics as well. But you'll see that in just a moment. So finally, what ties all of those hardware components together is the Artel software. You can see a little bit in this photo how our software can provide you data, essentially, at the end of the run. And in addition, we'll talk a little bit more about, what does all of that look like, right? What does a well-by-well result look like? What does channel statistics look like? What does dispense order statistics look like? But moreover, I just want to bring your attention to all the different regulations or standards that our MVS system complies to. So ISO 23783 was actually introduced in 2022, and that's an ISO standard that's specifically designed to talk about automated liquid handlers and their testing and verification. And then the system is also mentioned in ISO 8655 Part 7. So when we think about multi-channel pipette calibration, our system is mentioned in that standard as well. And then we've got clinical customers who follow QMS 23. Our system technology is also mentioned in that. And then 17025 accredited laboratories, GMP laboratories, and GLP laboratories. All of those customers have our systems and are able to successfully use them to verify or calibrate devices in their laboratories. And then last but not least, the Artel software also has an add-on module for 21 CFR Part 11 compliance. So if electronic records management is important and it's critical for your laboratory, especially when it comes to audit trail and electronic signatures, the Artel software has a module that can help you with that. So why would you pick the Artel MVS system versus something else? Essentially, when you think about all of the different factors that come into play, the liquid handler, the reagents, the tips, the temperature, the operator, what type of mixer are you using, the detector, the plate type, what we've done with our MVS system is we've validated and removed all of the different things that might cause variability in the read, which at the end of the day provides you with readings that are symbolic or provide you information on how the liquid handler is performing with its specific tips. So you don't have to worry about variability being introduced from the reagents or from the system hardware components. We've taken care of the validation for you. Okay, I've been doing a lot of talking, so let me go ahead and talk a little bit more. So when we think about the MVS system, it's not just a verification system. There's a lot of other uses where the system can be implemented into your laboratory procedures. So certainly from moving from left to right liquid handler verification, the system can certainly help you evaluate liquid handlers and determine which one is going to be the most suitable for the work that you need to perform. Operator training. So operator training could come in the form of pipette operator training for multi-channel pipettes, or perhaps you're training an engineer on optimizing automated liquid handlers. You can certainly use the system for that. Method transfer and scale up. So the moment that you decide to take that manual assay and transfer it over to the automated side of the house, how do you make sure that every step along the way of that assay, that volumes are being processed and dispensed correctly? Our system can help you with that as well. Liquid class optimization. So earlier I talked about the fact that we understand that not everyone is just using water-based solutions and sample types. So being able to dial in your automated liquid handler settings based on the different liquid classes that you might be running, that's an important thing to do as well. Labware qualification. Earlier I talked about maybe you want to source different tips for your automated liquid handler, or different types of reservoirs. How do you make sure that those tips or those labware items perform well compared to their originals? Our system can help answer the question for that too. Perhaps your automated liquid handler has an onboard mixer on board. How do you make sure that the mixer is mixing properly? Our system can help answer that question too. And then operational qualification and performance qualification. Yes, the MVS can help with that. And of course, interim verification and calibration, just to make sure that your robot's not drifting from the last time that it was formally calibrated. So a lot of different uses, all from one system. So earlier I mentioned that I want to talk to you a little bit more about liquid class optimization, and a lot of you might be familiar with what that means, but some of you may not be. So for those who aren't, let's talk a little bit about it to understand it a little bit more. So liquid classes are a group of settings that are optimized for specific items such as labware, volumes, or sometimes even the environment. And those settings can include adjusting things like pipetting speeds, whether or not you have your automated liquid handler pre-wet its pipette tips, adjusting the aspirate and dispense heights, and so on and so forth. So there's a lot of different settings, depending on the automated liquid handler, that you can adjust based on different things that you might be running or different environments that you might be testing in. So this slide just provides a little bit more detail in how an automated liquid handler can change results dramatically. So over on the far right-hand side, or far left-hand side, I should say, you'll see various robot settings that were adjusted with iterative testing performed throughout each change. So in this particular case, the liquid class for the serum sub-solution was finally dialed in after making 8 different sets of changes. So we began with an inaccuracy of minus 6.9%. So this robot started with under-delivering by approximately 6.9% and had a CV of 2.7. But then after we made a lot of those iterative step-by-step changes, we were able to achieve an accuracy of 0.8 with a CV of 0.3. So pretty drastic improvement for sure. All right, so now that I've finished talking about all of those slides, let's get into the live system demonstration. So I'm going to go ahead and stop sharing my screen because I'm going to share a different screen with you. Okay, so bear with me for just a moment. Great, and I'm going to share my screen again. This time you're going to see what we call the Artel software, which is the MVS system software. So if I could get a verbal confirmation that that's what you are viewing now, that Artel software, that would be great.
Yep, we can see it.
All right, excellent. Thank you. All right. So this is the Artel system software and a couple of pieces of information that I want to provide. So this software is used with the Artel MVS system, but it's also used with the Artel PCS system. It can also be used with supported balance models for measuring volumes that are greater than 5,000 microliters. So there's a lot of information that gets housed here. You can also house external reports from maybe you sent out pipettes to a service center and they repaired your pipette and sent it back to you. Artel can house all of that information, operator assessment reports as well. We've got a built-in operator assessment module for pipette operators in the software as well. So a lot of different things, and I'm really only showing you just a small piece of what the system does today. So if you take a look, this is the home screen, right? And it's meant to be very intuitive. If you take a look at this Get Started bar, when you first receive a system, what will happen is you might be thinking, okay, well, where do I start? This Get Started bar walks you through a very logical sequence of getting started. I don't know how many of you use crock pots, but I like to equate the preparation of the software to getting all to the, to very much being related to preparing ingredients for a crock pot. All the work happens up front, and then you throw everything into the crock pot and you press go. So all of the work happens in the software up front, where you're adding your users, you're adding locations for where your automated liquid handlers might be located. You're adding your MVS instrument, which is a one and done type of task. And then you're adding devices and plans. So I've already done steps 1 through 4. So I'm not going to do that today. But what I am going to do is I'm going to walk you through adding a device. So I'll go ahead and select Add Device here. And today I'm adding an automated liquid handler. So let's go ahead and click OK. And every time that you're within the software, if you see a red asterisk, that means it's a required field. So I'm going to go ahead and click on this ellipsis, because the first thing that I need to do is I need to tell the software what type of system am I trying to test today. And if you take a look at the drop-down box, you can see that we've preloaded a lot of different systems for you. So you'll find a lot of your very frequently used system here in this drop down. But if you don't see the system that you're working with, not to worry. You can certainly click on this plus sign and easily add manufacturer. So maybe the manufacturer of the automated liquid handler that you have isn't listed. You can easily add it. I'm going to go ahead and click cancel. And today I am using an epMotion. So I'm going to go ahead and select OK. And the moment I do that, I'm now being prompted to enter my liquid handler ID. So I'm going to go ahead and just enter today's date for the liquid handler ID. This description and the serial number, those are optional fields, so I'm going to leave those blank. But the location and the owner, I'm going to click on the ellipsis and let's select microbiology. And I'll go ahead and assign an owner as well. So this is essentially the robot, but this particular robot has a number of different size heads. For this epMotion, I have a single channel head. I also have an 8-channel head. So next, what I need to do is I need to go to the Dispense Head tab, and I need to tell the system about the head that I'm testing. So I'm going to go ahead and click on this plus sign, and you can see that there aren't any heads listed for this Eppendorf manufacturer. I'm going to click on the plus sign again, and I'm going to load my 8-channel head. And you can see the Eppendorf is the default manufacturer because that's what I selected initially. And I have an 8-channel head, and then these next fields are optional. So I'm just going to leave those blank. And now we can see that there's an 8-channel head there. So I'm going to go ahead and click OK. And my 8-channel head is still there. If I go back to that detail screen, again, we can see Eppendorf epMotion. And then I'll go ahead and select Save. So now we can see that that automated liquid handler with the 8-channel head is now in my liquid handlers list. So I'm going to go ahead and head back to the home screen, because the home screen really is where you can find pretty much everything that you're looking for. So next, what I'm going to do is create a plan. So when I click on Create Plan, there's a few different plans. So remember, this software is meant to be used for a lot of different tasks. For today, we're going to perform a liquid handler verification. So I'll go ahead and select OK. And then what I'm going to do, so for today, I filled an entire 96 well plate with 100 microliters. So I'm going to go ahead and just call this verification plan 100 microliters, April 15th. And then at that point, I have an option to select, am I going to be testing this device in a 96 well plate or a 384 well plate? So you certainly have the option to purchase the system just for 96 well usage or for both 96 and 384 well plate usage. But I'm going to leave that at 96 wells. And then I have to select the number of channels. So by default, it defaults to 8, but if I had a 96 channel head that I had for the epMotion, I could certainly add that, but it's an 8-channel head, so I'll select 8 today. And then over here is where you determine what type of evaluation criteria do you want to assign to this test. Now, you can choose to evaluate just inaccuracy or just imprecision, but most customers want to look at both of those statistics. So I'm going to go ahead and select inaccuracy and imprecision. And then you also have the opportunity, or the option, I should say, to include your channel statistics in your evaluation criteria, as well as your dispense order statistics. So I'm going to uncheck the box for dispense order statistics, but I am going to leave channel statistics because I want to be able to see whether or not I'm having a channel issue with this 8-channel head for this robot. So next, what I need to do is I need to click on dispense steps, because this is where I tell the system what are the volumes that I'm testing at, how many replicates, and where are those replicates and those volumes mapped on the plate. So for example, let's say that I wanted to test this particular device at 10 microliters, 4 replicates with an inaccuracy and imprecision spec of 10%. At that point, I need to select a color for how I'm going to map my plate. And this is just a little helper video. So I'm just going to click on do not show that again. And then I can map the 10 microliter replicates here. So let's say I also wanted to test 50 microliters. I can certainly add 50 with 4 replicates. And I'll also add my statistics for the 50 microliters as well. Select a color and add that. So you can essentially keep on adding multiple volume dispenses with different statistics, as well as multiple plates. I could essentially add several different plates just by going up here and clicking this add plate sign. And so I could conceivably be running 3, 4, 5 plates, or even just a single plate. But what I'm going to do is I'm going to take these plates away that I just added, and I'm going to clear the plate, because I actually want to just add another dispense plan. I'm going to delete this one as well, because the entire plate is filled with 100 microliters. I'm going to go ahead and select 100, 12 replicates, and I'll go ahead and put a specification of 7 and 7. I'll go ahead and scroll down. I'm feeling a little bit like this purple today. And then I'll go ahead and map my plates. There's my 100 microliter, 12 replicates with this 8-channel device. So you can see that I've only got one type of orientation to go from, vertical. I can't go horizontal with this 8-channel device. But the other thing I want to show you is, let's say that you have a problem channel that you're aware of. Let's say that you know for a fact that the second channel in this device is problematic. You can choose to exclude the channel in your statistics. Or even if you had a problematic well, you could exclude just that problematic well. I'm going to re-include the channel, actually. Bear with me, I'm going to exclude that well and then re-include this channel. So that way we can see the data for all 8 of these channels. So this looks pretty good. I'm going to go ahead and select approve and then click OK. So now I'll head back to my home screen. And there's a couple of different ways that you can start a verification, but I'm going to click on this Verify Liquid Handler shortcut. And you'll notice that there's a couple of different options. There's an option to perform a scheduled liquid handler verification, as well as an ad hoc liquid handler verification. So the Artel software also has the ability to run scheduling for you. So maybe you have some automated liquid handlers that are scheduled to be verified once a month, and then you've got others that are only verified once a quarter. The system can take care of the scheduling for you and send automated emails reminding you that those particular devices are due for verification. So there's also an optional email feature within the software where you can have those emails automatically sent to your inbox, just reminding you that certain things are due. So I'm going to go ahead and select Ad Hoc Liquid Handler Verification, and I'll go ahead and click OK. And then from here, you can see I have some options, right? I have to be able to select the liquid handler robot that I'm testing, as well as the verification plan that I'm testing. So it happens to be that the robot with the 8-channel head that I created earlier is already highlighted here, as well as that verification plan that I made earlier is also highlighted here. I can also choose to have a verification reason as well. This is just an interim verification, so we'll leave that there. And then I can double check that this is the volume that I'm wanting to test. These are the specifications, and this is just information about the orientation as well as the different statistics that I'm measuring. So I'm going to go ahead and select Start Verification. But before I do that, I'm going to change my camera angle. So now what you see is the system hardware. So you can see that I've got my plate reader, I've got a shaker, and I've got all of my bottles of solutions, and I've also got a plate here. So those of you that are interested, you can click on the thumbnail video that shows the hardware if you want to see the hardware close up. And then you can alternately click back and forth on that thumbnail to either see the software or the hardware. So I'm going to go ahead and click on Start Verification. I've got a couple of different MVS systems that I've mapped to this software, but this second system is the one that I'm using today. And now we're just going to walk through the software steps, and we're going to do everything that the software asks us to do. So first things first, the software is asking me to scan Qual-Assure A. So one thing I want to show you, hopefully that comes up okay, is that this bottle of Qual-Assure A runs from 50 to 200 microliters. And because I dispensed 100 microliters throughout the plate, I have to use the Qual-Assure A solution. The next I'm being asked to scan the diluent solution. So the diluent solution is meant to be that internal standard to make sure that we are filling each well of the plate to a specific working volume. In this case, each well of a 96 well plate has to be filled up with 200 microliters of total solution. So because I only dispensed 100 of the A solution, I also need to dispense 100 of the diluent or the blue solution. And you'll see that mapped in just a moment. So the next thing the system is asking me to do is to scan the verification plate. I go ahead and do that. Right. Next thing the system's asking me to do is scan the baseline plate. So let me go ahead and do that. I'm just going to run the baseline real quick for you today. The baseline essentially is the instrument 0. I'm going to skip the shaking step. I'm going to insert that plate into the reader and let the reader analyze that plate. So again, the baseline plate, it's run once every 10 hours. And it essentially tells the system, well, what does zero absorbance look like? So remember, we are based on a dual dye ratiometric absorbance technology. Even though this only takes 1 minute, it feels like a little bit longer than that. So my apologies. Thank you for being so patient. So another thing that I've done in order to prepare for this demonstration is I run the system calibrator plate as well. So there's a calibrator plate that comes with the system that you have to run every 10 hours. And that will make sure that your plate reader is in good working order and is ready to read the plates for you. All right, so now that the baseline plate's finished, I just want to bring your attention to this next software screen. So this next software screen just shows me what I need to do in order to dispense this plate correctly. So because I'm testing 100 microliters in 96 wells with 12 replicates, there's 100 microliters of solution A and 100 of diluent. So what I'm going to do, just for the sake of not making you wait too long, is I'm going to change the shaking parameters. Normally I would shake for 60 seconds, but for right now, I'm going to shake this plate at 25 seconds, just so that we don't have to wait too long. So I'm going to go ahead and place the plate on the shaker, make sure it's in there, and then I'll go ahead and select Start Shaking. So this orbital shaker is going to do its work and shake those two dyes, that diluent, which is that blue dye, which is non-quantitative, and the red dye, which is my 100 microliters. That's my sample under test. Just shaking those two dyes together, making sure that they're nice and well mixed. All right, so that happened pretty fast. So I'll go ahead and take a look at the plate, make sure I don't have any errant bubbles, no debris. Everything looks good. So I'm going to go ahead and insert that plate into the plate reader and select Start Reading. We'll also take approximately 1 minute, and then we'll see the results that we have dispensed from this epMotion. All right, we're almost finished. I know you're all very excited to see the results. I know I am too. Okay, so we'll go ahead and select Finish, and I'll click OK. What I'm going to do is I'm just going to change my camera back to me because the hardware is finished. There isn't anything else to see there. But what I do want to show you is the results that we just received from that plate that we ran. So the way that I like to look at my results is I like to have the system show me a heat map. And the heat map just shows me all of the volumes from low to high with assigned coloration, which is kind of neat. But all of the information you would expect to see about your liquid handler verification, information about the robot itself, information about the dispense head, information about orientation and all of these things, the date, who's running it, all of that information gets captured at the top of the report. And as I scroll a little bit further, you can see some information as well that provides me dispense step information. So if I were running 3 different volumes, I would have 3 different dispense steps. But since I'm only running 1 volume, I only have 1 dispense step. And this just shows me target volume, the number of replicates for that dispense step, which solution I used, and then also information about the shaking. You might remember that I actually reduced the shaking time, down to 25 seconds for you. So then we have volume statistics. So these volume statistics are the statistics for the plate overall. So if we take all 96 wells and we take the statistics for each of those wells together, the inaccuracy is 0.82%. The imprecision is 2.32%. So well within my specifications that I had assigned, a plus or minus 7% for inaccuracy, or equal to or less than 7% for imprecision. And then we also get mean volume information and uncertainty information too. So we've built in the MVS uncertainty measurement for the system into the software for you. Now, these are channel statistics. So this is a really important thing to look at. With ISO 23783, as well as ISO 8655 Part 7, when it talks about the verification or the calibration of multi-channel devices, every channel has to pass in order for that verification or calibration to be a passing test, if you will. So you can actually see the channel statistics. This was an 8-channel device, and here's channel 1. Channel 1's delivering an accuracy of 0.99%. with an imprecision of 2.69. And then if we take a look at channel 8 is under-delivering. You can see that its coloration for the channel statistic is blue. Its inaccuracy is 0.59. Its imprecision is 1.86. But each of these channels are passing. So that means I've got a passing verification for this epMotion's 8-channel head. Now I still see my, oops, I'm so sorry. I still see my dispense order statistics. They're just not included in the pass or fail determination for this test. I still get visibility to them, which can really be helpful. If you take a look at the dispense order statistics for dispense 11 and 12, I want you to take note that all of dispense 11 on average is a little low, and all of the dispenses for dispense 12 is a little high. So let me show you the plate information. So what I did, here's dispense 11. You can see that everything is blue in that entire dispense. So all of the results were low for that dispense. But then you can see in the 12th dispense that everything was a little bit high. What I did is I removed some of the volumes from the 11th column and I transferred it into the 12th column so that you can kind of see what happens when you assign that heat map to the report for the well-by-well results. So it's kind of neat, right? We can also see that this very first dispense is a little bit higher. And then we've got some other different types of dispenses. When you see white wells, that means that that's the mean of these 96 data points. So white is just the mean of your data. It has nothing to do with the target volume. And then, of course, everything is either lower or higher than your mean volume for that particular data set. And then last but not least, we see information about the materials that were used. So remember, when we think about NIST traceability for the results from this system, everything is barcoded and everything gets scanned during a verification. And that's what provides you the NIST traceability. So all of the information from the bottles that I scanned, as well as from the plate that I scanned, they're all captured here. And then last but not least, information about the system itself. So information about the plate reader, the shaker. There's information here about me being the operator. And again, if 21 CFR Part 11 compliance is important to you, as well as being digital, the compliance suite module add-on for that, the Artelware software, can give you electronic signature information. So you're not necessarily staring at these blank lines. And then, of course, you can see that the status for this verification is approved. So if I scroll back up to the top, I have an option to either, I can export this report to PDF, Word, or Excel, or I could also print it to a full-size printer, but I don't have a full-size printer hooked up to this laptop, so I'm unable to do that this time. But apart from that, that's what I wanted to show you today for today's demo. Does anyone have any questions that you'd like to ask now that we're at the end of the demonstration? Question, feel free to take yourself off mute if you'd like to ask your question. Sydney, thank you so much for raising your hand. I see that you have a question. How can I help? Presentation, can we show to the customer directly? I believe that you can, for sure, yeah. Additional questions. Can this be used for single channel calibrations? Hi, Steve. I know you. Yes, the MVS system can be used for single channel calibrations. The thing to keep in mind, there's a couple of things. Number one, so the first thing to keep in mind is that you have a volume limitation based on how much you can dispense into any single well. So you could use single channel pipettes, but then your maximum volume would be 350 microliters in a 96 well plate.